Hello, my name is Byron Franklin. I was a quartermaster in the Navy for 27 years, and I developed several techniques. I want to talk about radar in this particular technique. The radar navigation manual has a few techniques that are worthwhile. I want to show you two of them and go into detail on just one of them for now. The first one that I want to show in the manual is the Franklin piloting technique, which is the continuous radar plot. This was developed for a reason, and I'll get into the reason. The one I'm going to really expand on is called the special technique. I'll go into that in detail. The reason for these techniques being developed is some years ago the USS Intrepid, a carrier, came into Newport, Rhode Island and went up the bay and ran aground. It was in heavy fog and they really shouldn't even have attempted to come in. What they did, because there was admirals and governors and everybody at the pier, so they didn't want to satisfy them. They buoy hopped on the way up with heavy fog, which shouldn't have been done. So what I want to do is talk to you about what happened after. I was asked after, I wasn't on the Intrepid at the time, I was asked afterwards what I could have done to save the Intrepid from going aground. So I came up with two techniques, or developed two techniques. One is the Franklin piloting technique, which is in this radar manual, and the special technique, which is in here too. But let me explain to you what the technique special is. It really amounts to a smaller vessel, say, but a big carrier can use it also, or any ship. But the idea is to make range rings for your chart that you're going to use, and the spacing that you decide. Offshore you could make these range rings a mile apart, but here coming into port I made them 50 yards apart. So this represents the range rings on a radar. So this represents the movement of the ship in the center of this template, and what the range rings would look like as you travel up through the channel. Now, this explains it to a large extent. This is the radar, and this is the plastic template. So you look in the radar and you see how the range rings appear. Notice a buoy or something here. Notice it doesn't touch land here. Notice it touches land here. So the idea is just to take that and match it on the chart. It's a very easy thing to do, and you can do it fairly quickly. By just throwing the chart down, moving it around, you could see that it doesn't touch here, and by moving this chart to equal this chart, you can see a buoy down here at the bottom. Range ring actually covers that buoy. So this right now would be the fix. So all you do is lift it up and mark the fix in the center. A simple project, and can be done on almost any ship. This technique has been used in several ways. I've used it on aircraft carriers, submarines. In fact, coming out of New London on a high-class submarine, the radarman said no fix. I quickly laid this down, adjusted it according to what I saw in the radar scope, got a fix. They immediately came out with a fix right on top. It has been used in court cases to prove that a small vessel without sophisticated or a large amount of men can navigate using this alone, just by looking in the radar and matching the scope with the radar configuration. Now, what else can it be used for? Many other things. Here's another example where we moved the radar ring to where it matched the radar, and you can see the buoys. This buoy seems to be missing up here, but there's something right over here. There's something here that doesn't show on the chart. So this might be that buoy. The buoy might be out of place. This might be a ship coming down, so it can warn you of such things. So it can be used going up the channel and accurately navigate you up the channel. Another thing that it can be used for is to recognize the shoreline on the radar. Here's the radar, and here's a chart. Shows a ship here, which wouldn't be on the chart, but it describes how this beach might look. Here you have a sandy beach. It doesn't even show here. This thing juts out a little farther. So therefore, the ship on the end of this pier actually makes the pier look like it extends more. The high land here gives a good echo. The ship here kinds of blend in with the echo. This is the reason why a lot of times in taking bearings for ranges are always more accurate than bearings. But this is the reason why they sometimes get bad fixes. If you were to take a range off of here, you'd be including that ship. So the range would be incorrect. The same thing with here. A range off of here would be incorrect. You might take a range over here and get the sandy, and not get the sandy beach, but get all the way in here before the return signal. The signals are like a bunch of ping pong balls that are thrown out. The return depends on what it hits, how solid, the shape of it, the height of it, and many factors. So this helps you to recognize what an area looks like by taking the whole picture instead of only a radar return range. You get the whole picture here as to what the chart looks like, what the return looks like. So give it a try. You'll find it very easy to do. To make the scale, all you have to do is measure on the chart. For this particular chart, this particular range ring would work. Thank you.